All right, so let's start with the first question here. That is the women with breast cancer problem. So the hint starts us off with saying that if there are 10,000 women total, and we know that the statistic is that 1 in 1,000 women under the age of 35 will have breast cancer, how many of these 10,000 women will have cancer? So what we're talking about is the number of people in this cell right here. So here then what we have is the rate, right? So think about it, 1 in 1,000 times the total number of women, okay? So now this makes our job really easy because this cell and this cell need to add up to 10,000. So all we need to do is 1 minus, sorry guys, cell above. My computer's been really wacky lately. All right, so then let's move on, okay? The women with a negative result now, or a positive result, and has cancer. So let's go to the positive result because that's the second statistic we're given. 90% of women with breast cancer will correctly get a positive result, okay? So this is 90% of women who do have breast cancer. So we're only talking about this row right here. And now we know that 90% of them will correctly get a positive result. So here we're going to talk about the rate times the total women with cancer, okay? Now, this is just going to make it really super easy for us. 1 minus left cell, okay? Let's make that look prettier for you, yeah? Okay. So then now we have right here that people who do not have cancer, okay? So what is important about this is that the second statistic, 20% of women without breast cancer, so this row right here, will also get a positive result, okay? So what is our rate here? Well, 20%, right? So total women without cancer, okay? And now, make our job super easy again. 1 minus the left cell, okay? So what's left now is that you need to total this column here and this column here. So basically the hardest part is done, all right? Okay, so let's move on then. All right, so before we move on, I want to remind you all of two things. First of all, the chance of an outcome is the percentage of times one expects that outcome to happen when the process is repeated over and over again under the same conditions. And how you compute this chance is that you find the number of outcomes that you want and you divide it by the total number of possibilities, okay? So the first question here then, a woman gets a positive result. What is the chance that she really has breast cancer? So going back to our definition here, that the number of outcomes divided by the total number of possibilities. So total number of possibilities. This lady got a positive result. So all we're going to be concerning ourselves is with this column right here. Okay? And the number of the outcomes then is we're going to use this as our numerator, okay? This divided by this total right here will actually give us the chance that this lady who has a positive result actually has breast cancer. Now let's go back. The second question is that a woman gets a negative result. What is the chance that she really has breast cancer, okay? So now, all we're concerning ourselves is the lady got a negative test result. We don't care about people who get positive. We just want to see that she has a negative test result. So out of this entire pool, what is her chance that she actually has cancer? So we're worried about this number right here as a numerator, the number of wanted outcomes, divided by this total right here. Okay, so those are the two chances that you want to calculate. Also, the second parts of each question you should be able to do. Just be careful that there's a percentage sign there, so make sure your calculations are correct. And that wraps up the breast cancer problem.